2-point charges, each positive capital Q, are fixed at distance capital L apart. A particle of charge negative Q and mass m is placed as shown in the figure above. What is this particle's initial acceleration when released from rest? In order to get the acceleration, we need the force. And in order to get the force, we need the field. Therefore, we start by determining that the distance from each of the positive charges to the location of the negative charge is L times the sine or cosine of 45 degrees, which is L times the square root of 2 over 2, or just L over the square root of 2. Then, the electric field due to one of the positive charges is Q over 4 pi epsilon naught L squared over 2, directed away from the charge. This simplifies to Q over 2 pi epsilon naught L squared. Since the field vectors due to each of the charges are perpendicular, we can use the Pythagorean theorem to state that the resultant field is that quantity times the square root of 2. Therefore, we have the field as square root of 2 times Q over 2 pi epsilon naught L squared. Since the charge is negative, the force is pointing in the opposite direction and has a magnitude of square root of 2 times Q over 2 pi epsilon naught L squared. Finally, the acceleration is force divided by mass because of Newton's second law. So the magnitude of the force is the square root of 2 times capital Q over 2 pi epsilon naught L squared m. This is option A.